Hello and welcome to episode 7 of Network Collective. In today's episode, we have an excellent panel of guests that's here to talk about the good, the bad, and the ugly of extending layer 2 networks. So joining us today to talk about extending layer 2 networks, we have 3 excellent guests. We're going to give them an opportunity to introduce themselves, and we are going to start it off with Chris.
Thanks, and thanks for the inclusion in today's show. I really appreciate that. So I'm Chris Kane. I've been in the networking industry for a little over 20 years. I'm currently a systems engineer and love bantering about everything networking.
Excellent.
And you can find me all over the web, but primarily at CCIE 14430 on Twitter.
All right. Thanks, Chris. Joining us for his second show with Network Collective is Kevin. Kevin.
Yeah, thanks, Jordan. Appreciate coming back on the show. My name is Kevin Myers. I'm a network architect and co-founder of IP Architects, which is a firm that does white box integration for enterprise and ISP.
All right. And last, certainly not least, is our good friend Nick. Nick, why don't you tell us a little bit about yourself?
Hi, everybody. Thanks for having me in the show. According to my accent, you will recognize the fact that I've been raised in the US, right? So right. I'm a French guy who relocated in the US 7 months ago, and I'm living in a great city of Austin in the middle of the Texas. And I'm a network engineer. I'm specialized in routing and switching, data center, and unified communications. And you can find me at vpacket.net, and you can find me on Twitter as well at vpackets. All
right, let's get right into it. So when we're talking about layer 2 extension, what are some of the kind of motivating factors? What are the reasons that people are looking to extend layer 2 beyond just a single physical location?
Yeah, I think that's a good question. Layer 2 extension's been around for a while. I think we all started out as what I like to call naked spanning tree, and lots of battle scars from trying to do layer 2 extensions that way. And then the market's kind of matured, right? From each manufacturer, each vendor has come up with newer ways for us to be able to accomplish this task. And it seems like the goals are generally around projects that include either temporary data center interconnect, or what we often refer to as DCI. There's also permanent DCI, where people are trying to acquire more of an active-active data center philosophy. Of course, active-active means different things to different people in the stack. But then lately, it seems like a big area of conversation has been around hybrid cloud. And how do I extend out to a single hybrid cloud provider or potentially multiple hybrid cloud providers? So I think that's really brought DCI in and of itself to the forefront of how we're going to solve these problems that the network team is being asked to provide solutions for.
Now, I mean, I'm seeing, I guess, on my customer base, quite a few people who are approaching this from a disaster recovery standpoint. Are you guys seeing that as well?
Yeah, absolutely. So it seems like that was some of the first use cases. If we go way back and people that engaged things like SunGuard, hey, I bought a little bit of space, I can turn things up, and then realizing that maybe that doesn't meet the business's objectives for things like RTO and RPO. And so more of maybe a primary, secondary, where the secondary isn't fully lit all the time, but let's minimize the amount of moving parts that we have to touch in order to restore service in another site. And what I hear more and more from even the mid-sized enterprises, let alone the bigger ones, is that, hey, if we've spent all that money on the facilities, the routing and switching and the power and the cooling in those other locations, what can we do to take advantage of that and actually switch production packets in those facilities as well? So some people are still in that DR mode, but I think a lot of others are looking at it from a dollar standpoint and saying, I'd rather stuff not sit there dormant. I'd like to take advantage of it if possible.
So you mean utilizing all the resources that you spent money on and not having to do that? Yeah.
Yeah, exactly. At least some set, right? I mean, it may not be full-blown active, but at least, hey, let's switch some of our applications out of another location instead of just sitting there and hoping that from an audit standpoint, our DR tests actually work, knowing full well that we don't always do our best to adhere to an annual DR test.
All right. So let's just say that we're going to be doing a layer 2 extension for whatever the motivations are that we've talked about. What are some of the some of the factors? What needs to be considered? What are some of the things you need to think about before you start a layer 2 extension project?
Well, I think
after you, Kevin.
I think so, essentially. I think we've talked a lot about isolation of the layer 2 environment is critically important. And I think there was a lot of agreement in isolation of spanning tree, BPDO filtering. And I think a lot of that comes down to the protocol that you use to do that isolation and do that extension, because, some of them handle it inherently. Some of them you're going to be doing a manual BPDO filtering between the data centers. So, to me, that's the first most critical thing, is to figure out what are the spanning tree environments, look at the data center. I know one of the things I looked at was, do we have any misbehavior in spanning tree before we join, look at these, is there something that's not behaving well in one data center, let's get that corrected. And then we'll go ahead and, maybe either create a neutral spanning tree, between the two, which, is not as done as much anymore. I don't try to do it. It's more just filtering and using some other overlays to take care of that. That's at least one of the first things that I look at.
All right. Well, you're talking about some solutions to problems. Maybe we should start there. Maybe we should start with what are some of the risks? I mean, you're talking about things that we can do to look at spanning tree and possibly some other mitigation techniques, but what, I guess in the considerations, like what are we trying to fix? Like, what's the problem?
Oh, as far as the justification and use case, I think, the biggest ones that I've been faced with are, you have applications that are, essentially for whatever reason, not capable of being highly available at layer 3. And I think probably everybody, in the podcast has dealt with that at some point or other, whether it's because it's part of a network migration, whether it's because you've got, an enterprise has this application that nobody wants to spend the money to rewrite, whatever the case is. At least for me, that's one of the biggest things that I've seen as a driver saying, hey, we have this application, we want to do something with it. And so we've identified L2 DCI as, the mechanism by which, we want to handle that.
Okay, go ahead.
Yeah, and something that we also need to consider when we are talking about layer 2 data center interconnect is the size of the data center, is the size of the company that we are trying to help when we are doing such things. I mean, it's not the same as building 2 small data centers in the same city and interconnecting just with a trunk and a dark fiber. Mm-hmm. And if you have another company that has thousands of virtual machines and you need to do real DCI, and by real DCI I mean layer 2 over layer 3, and that's definitely not the same kind of technology, definitely not the same kind of problem, and obviously not the same kind of money that will be that will be spent by that company.
Mm-hmm. So, Kevin, you brought up something interesting when you were talking just a second ago, and that's talking about applications that have layer 2 adjacency requirements. I hear that, and I've heard that a lot. I do have to say that, like, when you start pulling back the covers on that, the requirement is not always a requirement so much as it is we don't understand it, or we don't want to rewrite it, or we don't want to do something else. So we're going to do this here.
That's a great point.
Right.
Yeah,
and so
that's an excellent point. So.
In 2017, here's the question. In 2017, right, as we're sitting here recording this, how many applications do we really have on our network that are running now that require layer 2 adjacency? I mean, I know that there are some. I'm just curious if we could find some use cases.
I would say if you have to deal with mainframes at all, or you have to deal with really truly legacy applications that have not been built anytime recently, it happens a lot. Because, for one thing, you get applications that don't use DNS calls, that are hard coded, and you either can't or somebody won't, go do it. Because a lot of times it's great to say, let's push back and we need to be able to re-engineer this. We need to push this to the app guys. What happens if you get into a company that has no app guys, or has somebody that doesn't even know how to recode it? And so they come to you and say, look, this has got to move in 6 weeks, and we don't know how to deal with it. The application guys don't even know what ports the thing runs on. They don't even know, what ports do you live on this? And so you look at this and say, okay, if we're going to move this, or we're going to deal with this, or I'm going to meet this requirement, whatever it is, whether it's I'm going to migrate between data centers, or whether I'm going to say, okay, this needs to live in 2 data centers, and you have no control or ownership over the application stack. That's a lot of the times that I get forced into L2 DCI, at least from what I've seen.
Yeah, and I've had that same experience. Mergers and acquisitions lead to that quite a bit, right? Where, an acquiring company may have the strategic data centers. They buy a company who has 1 or 2 data centers, and it's determined that, hey, we're going to let those fold. We're going to evacuate those data centers. How easily can we get those workloads, those apps, that data from a retiring data center to a strategic data center? And that, good use case for what we probably call a temporary data center interconnect.
But I think we have to put a distinction between temporary and long-term layer 2 DCI. And especially when you're talking about applications that require layer 2 adjacency. And I think we push back harder when it's a long-term scenario than when it's short-term, because ultimately that app is going to need more care and feeding. It can't live at layer 2 forever. And I think it's important to keep saying that. I mean, you may not get traction on it the first time or the second time or even the 5th time, but to continue to highlight the risks associated with it, if nothing else, to be okay when there is a problem down the road, right? To know that you called it out. Because I think sometimes I've seen many network engineers behave in ways that they wouldn't because they felt forced to. And I think sometimes we have to just speak up, even if we don't feel or don't believe we'll be heard, or we know that there's a business case. We still have to call that out as these are the risks and here's what we're doing to mitigate those risks. But ultimately, you're going to be forced into these limitations as long as we stay with this legacy application.
That's in the context of that long-term DCI solution.
Right.
And ultimately, I mean, I've been doing this for 10 years almost, and almost every single time I was connecting data centers, it was like Nick said, a layer 2 trunk city to a geographically close city. And it was a temporary solution that we set up to do some sort of migration. And I'm kind of okay with that. I mean, we re-IP our sites. We maybe lean on DNS for the applications, and obviously working with app teams, that's its own show. So I think for those short-term migration, maybe you want to call them remediation or mitigation projects, I don't see it as such a horrible thing like we like to make fun of on Twitter and in the business.
Yeah, no, that's a great point, Phil. And I think, too, you brought up a great point in so that when they're really close together, that is an entirely different kind of DCI, scenario. I've had to actually do DCI between different countries. And, man, that's a whole other experience. Yeah. When you've got to take data centers in different countries because you've got this huge amount of latency. So, not to jump too far ahead, but we talked about in the show notes tromboning and some of these things we're going to get into later. And the further the latency is apart, that becomes a huge deal. So certainly the distance plays a massive factor in how impactful layer 2 is when you're extending it.
Yeah, I didn't mean to make light of it in the sense that geographically close locations, it's no problem. It's a temp. You still have your a large failure domain to deal with now that you've doubled it, and however that's mitigated and adjusted. So there's still certainly some serious concerns there, just different,
Yeah, but you're 100% right. It's a lot easier when they're close. It really makes things a lot easier when you're trying to do what you're talking about. So I think you're on target there.
Yeah, I think frankly that's been pretty much my only experience. I mean, well, as far as at being a permanent solution, that's a permanent, or rather a temporary solution that we're using. And the long-term goal, whether it's 6 months or a year from now, is to move away from that entirely. Whether it be exploring SD-WAN options or it's exploring, whatever private links we're going to use, and then run. But maybe we're doing a dual DM VPN. That's something that I've worked on where we had active data centers, and that's how we did it. So as a temporary solution, but on the roadmap to a different layer 3 permanent solution.
And also the kind of technologies are completely different if the data center are closed. It's like you would do just a regular trunk for geographically the closed data center. But if the distance is very high, you would do some kind of VPLS or OTV or VXLAN VPN, and now NSX and ACI and stuff like that. So the scope of the technology is so wide that it means completely different things and different argument. Even the hardware can be different.
Well,
if you want to do OTV, you're stuck with the Nexus 7K and maybe some ASR. So it's completely different.
Well, that presupposes that you know what kind of control plane you want, you know what you need, and what features are necessary. So
yeah,
when you bring in those types of technologies.
Yeah.
All right. So we've talked about some of the advantages. We've talked about IP address co-location. We've talked about, redundancy for apps that require layer two adjacency. I think one of the other things that we haven't hit on yet, and it's funny because I think this is the one I hear the most, and I don't know if this is a shared experience or just my experiences. Usually when I start a layer 2 project with a customer, the big thing is I want vMotion. I want to be able to move my VM from data center A to data center B, and not have to change anything on the VM at all and just have it work. Right. I think, I see nodding, so I'm going to assume that there's some agreement there and smiles and whatever.
That's probably the primary, to be honest. Right. I mean, in my experience.
Do we feel like it's been a more common topic since live migration of virtual machines has been possible?
It is the number one topic in every meeting when you're talking about layer 2 data center interconnect. You know what would be the first argument that will be raised by anybody. It will be vMotion. That's it. And you can spend hours just discussing about vMotioning VMs between point A and point B. That's the main goal. That what all of the people are trying to achieve.
Okay.
So there's your use case, and that's going to drive, what are we going to use for our control plane? What are we going to do to drive down latency? So that's a good point.
I mean, that's probably a whole show in itself, but I think there's a lot of misconceptions in that use case. I think that there's,
what do you mean?
There's some presuppositions. VMs and servers as a whole have gotten larger, not smaller. Moving that much real-time synced memory across distance, as Kevin was, alluding to, when you start adding latency, it becomes a dramatically longer event to vMotion from one data center to another. Yeah. And so
does vMotion have distance requirements? Doesn't it have some kind of distance requirements?
There's limitations, but they keep getting longer. And I hear about these, these guys who've proven out a proof of concept, vMotion over, 120 milliseconds of latency or something like that. And I go, why?
Book of world records in networking.
Because how long did it take to make that vMotion happen?
Yeah, all night, right.
To synchronize all those things. And so, and I think especially as we talk about disaster, and because it's almost always, we're building a disaster recovery data center and we want to be able to vMotion our VMs. And I don't remember the last disaster that gave me enough notice to vMotion my stuff. So I think it's kind of a funny thing in there. I just wanted to bring it up because it definitely is one of the arguments I hear all the time, or not arguments, but one of the motivating factors is I want to be able to vMotion. Now, if I want to be able to vMotion has something to do with regular operations, then it's worth taking a look at. Maybe there's a valid reason there. But yeah, it gets really difficult. I think the assumption is that just because I have connectivity, I can vMotion. It's not necessarily true. It gets really, really hard as distance starts happening. And VMware has gotten better about it. They've been able to do it over longer distances and more efficiently, but it's still not perfect.
Those are good points to bring up as far as working with the business or working with the applications owner to really define what problem are we trying to solve.
Well, I think that's a critical thing in all this, right?
We have to start there. Yeah.
Right. Because there's going to be times when, a layer 2 extension, data center interconnect, whatever the technology, whether it's just a trunk or some sort of like OTV or overlay or whatever the solution is going to be it absolutely makes sense. There's a reason why these things exist. But I think there's a lot of times when there's misconceptions. And so I think we really, us as engineers, we have to dig down and find out what the real requirements are. And we have to have those conversations with the business. And sometimes it's a really hard conversation. I say that from a VAR perspective. I've had several hard conversations where you would go in, we have the conversation. The network engineering team comes to the realization that, wait a minute, we don't really need layer 2 adjacency. Like we're talking about it, we don't need it, but they internally can't convince the app owners that that's true. And so then it becomes a political thing rather than a technical thing. And then you're just kind of throwing the ball in the air, right? Like what's the best solution?
Yeah.
Do you solve the political problem or do you solve the technical problem?
Mm-hmm. Yeah, and you're right on target with that, Jordan, because I think, as a consultant, that sometimes you even have to know what questions to ask them that they don't even know to ask, so that you can kind of flesh out that business requirement and see what is we really trying to do here? What problem are we trying to solve? And I wanted to add a few more that I think I've seen in the enterprise space. Storage is actually one that I think about it that I didn't have on the show notes, but certain kind of storage replication boxes like to be directly connected. For certain reasons. So an overlay for storage I've seen before as a requirement. That could be one that you could run into. Directly connected subnets for some kind of network devices, whether it's like a router, an edge router that you want to be directly connected because it makes the routing path simpler, like BGP edge routers. I've also seen it with security devices that need a heartbeat and they just happen to be separated between data centers. You can do a directly connected subnet stretch between data centers. I've seen that done. And then this is a little bit outside our enterprise, but video, if you have to deal with multicast video, sometimes extending that can make a lot more sense than introducing the complexities of a multicast routing overlay into your network. So I've seen that as well.
Okay. So let's talk about some of the risks, right? So I think that, correct me if I'm wrong, but the general conclusion is short-term migration. Yeah, let's do it. Long-term, whoa, let's make sure. Like we got to make sure we actually understand the requirements. Is that fair? I mean, it seems like a fair summary? Kevin's
That's
like, maybe.
That's a fair summary, and I think what we're about to talk about next, if I'm reading the notes correctly, is the reason why that's a fair summary. So
right. So I want to talk about long term. Why is the general consensus that long term requires some hesitation? What is it about layer 2 interconnect that makes you go, I don't know?
Well, broadcast, right? I mean, so many protocols that later to broadcast. You have a host that ARPs that goes mad. You've got BPDUs. You've got all these protocols that depend on broadcast. And the farther that broadcast has to go and the larger your failure domain, the bigger the risk becomes. And so the more you have to think about what those risks are and how to deal with them. I mean, that's an overall summary. We can dig into the details, but that's how I see it.
Okay. Yep. Ultimately, a problem in the layer 2 realm in one DC can propagate to another, and so you have an unnecessary shared fate in the long term, which in the short term you can mitigate and deal with as your project progresses. That's kind of right.
Right.
Yeah.
And I think that's where the due diligence on the part of the network engineer really comes into play is, okay, once we define the scope of this, what are my options? What tricks do I have in the bag? Whether that's with one vendor or multiple vendors, but to do your due diligence, right, and to have an informed opinion about how, what are the various ways that I can meet this requirement that at this point seems to be in concrete. I have my marching orders. I've got to provide this solution from a network perspective. Okay, what's available to me in order to provide that with the least amount of risk, right? And something that's not only, hey, I can stand up all kinds of stuff, but that doesn't mean it's supportable, right? For an operations team or for people they're in the firefighting mode versus someone who may be in an architecture or an implementation where they feel like they can set it, forget it, and walk away. So I think our part, very much so, is doing that due diligence to know what's the best fit for this particular situation.
Yeah, I agree with that. And there's an interesting, when we look at network architecture and design, there's a component of art and there's a component of engineering, right? Great point. And sometimes there's a creativity that can go into it. Like there's been a number of times there's a solution that I like using, or at least presenting when someone tells me that they need layer 2 extension or data center connect, and that is if they're building a disaster recovery site, do they really need the data centers to be active? And we talked about that can mean different things, but the idea is, do I really need this segment living at both at the same time, or do I just need to be able to recover segment A from data center A and replace it in data center B if data center A were to go away in some sort of automated fashion? That can be accomplished a lot of ways. Data center interconnect's one of them, but there's also, we can replicate VMs and hosts and have standby hosts sitting in a bubble. We call it, a DR bubble, where they sit there and they're just not routed. They sit there, they're just waiting. Data is replicated, it's all sitting there. All we have to do is flip a switch, turn off the routing from data center A, turn on the routing from data center B, and we can have those hosts living over there with the exact same IP addresses. We didn't have to change anything on the system. So we met the need, right? Because the need wasn't active data centers. The need was disaster recovery. The need was, I need to be able to, if a plane drops on this building here and it's gone, this building here can take over with the host with the same exact IP addresses. Yeah. And so I think finding out those requirements are absolutely critical, because you can come up with solutions that have less risk that accomplish the same things.
Yeah, but some people need also to understand that if you have a logical problem, not just a physical problem, if you have a logical problem in data center 1, that logical problem will replicate to data center 2, and then both of your data centers are down. So there is no point of doing that if what you are trying to look for is disaster recovery, because this is not disaster recovery, right?
Well, but that's the DR backup conversation, right?
Right.
I mean, they're different, right? And I think sometimes those terms get muddled. High availability, DR,
redundancy,
backup,
business continuity. Yeah.
Right. That they are different problem sets. And I think sometimes we don't clarify that in across the IT stack, not just in networking. It happens in networking, but also, is this a backup solution or is it a disaster recovery solution? And we need to be clear on that so that we can guide the conversation, because you're absolutely right. If your database gets hosed and you replicate that to your DR site, it's not going to do you any good because you've got the same bad data, right? But if your good database gets blown up by an airplane, as Jordan said, you've got a copy of it and you just turn it on. So that's not layer 2 extension, but it is important.
Well,
anytime we're talking about backup and DR.
When you're talking about a DR data center and storage replication, I mean, a lot of the time you're talking about enormous amounts of data on a regular basis, if not just nightly, something like that. But often it's, in places I've been, it's continual, and you need the layer 2 connectivity for that itself. So maybe not for any other reasons, but I think Kevin actually mentioned that before. So for that sole reason. So
I was actually going to say, Phil, on that, my first question is if it's going to be, well, I have several questions. It's going to be long-term or temporary. And that's, what are we putting on the other side of that layer 2 extension? Because if it's a layer 3 device, or something else that's, not terribly risky, I might leave it in place for a long time. We put overlays in data centers that connect routers or other layer 3 devices that stay for years without issues. So, that's not really a problem. So it depends on, what it is that you need to do and how you need to transport it and what that device is. And I think it's also, I think Chris Kane alluded to this because we asked this question. I've actually got one client in Europe that has layer 2 stretched across 3 data centers. And in their market, they have the highest uptime of any of their competitors, which is kind of odd, but they only do one thing. Like they're enterprise, but they only really have one app that they do. And it's one thing that they do well. And they've kind of mitigated, that L2 DCI where they need to, so that it really doesn't affect the other data center through multicast storm suppression, broadcast storm suppression, all the kind of Chris Kane talked about, I think in the notes, it's proper engineering. If you're going to do this, do the proper engineering and make sure that you don't kill yourself.
I think that's the key takeaway. If we can summarize the show right now, and I'll just go home, right, is the fact that you can do it, but it requires some level of engineering and thought, right? I mean, that's just, there's no way to do this without really considering what the implications are, knowing what your requirements are. It seems like there's this sliding scale, right? So distance is one of the components, right? How far? And as a function of that, what the latency is between the two sites, because that seems to matter.
That's really the issue,
right? Well, that's one of them. You have broadcast, you have the number of hosts, right? Because I think the more hosts you have on either side, the more chance of some sort of layer 2 broadcast issue being replicated. Now, we're going to talk about some of those mitigating factors in a minute, about how you can try to, and for the most part, control those things. But that's the risk, right? And then it's almost like also, what's the purpose, right? Is this just to live on both sides all the time as just an active thing, or is this, like you said, to put 2 interfaces of a external BGP router on the same inside interface and run HSRP or some routing protocol between them, so that it's super simple and I don't have to traverse over things? Like, that may be an easier use case to design for than running, /18 network that's really heavily populated in 2 active data centers. Like those are 2 different design.
I was just going to say, one of the risks we haven't really talked about either is complexity and and that layer 3 egress, right? So how are you going to deal with that? Mm-hmm. And that's a problem. It's a problem you're going to have to solve. If you got hosts in 2 data centers that are geographically not close together, and you're going to have different internet ingress and egress points at each side, how are you going to deal with that from a layer 3 perspective? And so those are other, at least maybe not risks, but problems that have to be solved that may lead to additional complexity, which may or may not be desired depending on your use case, right?
But that is solved by what Jordan said, which is being a network artist, which is my new title.
Network artist. Okay,
if you do that artistry. I did, Jordan, if you don't mind, I did want to throw one thing in. I've done quite a few wireless projects, and I know it's not in the show notes, but that's one layer 2 among many sites that I've implemented a whole bunch of times that I didn't really think of very much, where, you have your centralized controllers at like the school district office, and then you have 17 buildings around the entire city, and all the wireless comes back to there. And maybe that's different because it's their own fiber, but that's just something I was thinking about now, and I've never had any issues with that as long as it's designed properly. So, and again, it depends on the technology. If you want to do some kind of OTV between 2 data centers, you will have to filter HSRP between the 2 data center. That works for outbound, but for inbound, you will have to introduce another protocol, which is Lisp, in order to avoid traffic tromboning. So it's complicated. It's
right.
So just to add to that, this is an evolving technology, right? I mean, we've talked about naked spanning trees, how we all kind of started where just layer 2 was left to run wild and free between 2 data centers, and then VPLS came along and
free range BPDUs. Is that what I'm hearing?
Yes,
free range BPDUs.
Exactly. Right. So
now we put BPDUs in cages and pump them up with steroids, and I understand.
But a lot of manufacturers have seen that, have lived through that with their customers, and have provided solutions to make it easier for you to filter those things out, right? To reduce the heavy lifting, and I think more importantly, to reduce human error. So if there's something embedded naturally in the solution, then it cuts down on the amount of changes you have to make, the amount of changes you're talking about with your peers doing implementation peer review, and therefore reducing that risk. Because we all know, as good as the technology can be, human error still remains an incredibly significant factor in our outages or disruption of service. So I think, OTV was a great start. But I think a lot of other manufacturers have kind of taken that and run with it and grown. How can we simplify this to make it a little easier to implement and support, and yet still provide enough flexibility to meet the needs of the particular project?
All right, so we keep pushing there. So we're going to go there next. We're going to talk about the mitigation strategies, but just to sum up some of the risks, right? So we talked about shared fate. We talked about BPDUs, broadcast storms. We talked about ARP storm as well as potential issues. We talked about inefficient traffic flows. Mm-hmm. We've mentioned the concept of traffic tromboning. We haven't really talked about that. Maybe we should talk about that for a second. What that problem is, and then one of the other problems that we have is stateful device traversal. So this kind of ties in hand with traffic tromboning. So does someone want to take a crack at the traffic tromboning problem, trying to explain it, just so someone who may not be familiar with it can understand?
I would, if you don't mind. So having implemented several of these now with various technologies and various manufacturers, in the end, regardless, you still end up with, okay, I've got firewalls, I've got load balancers, or perhaps even in some cases WAN optimization, which often acts as a proxy and is stateful as well, right? So what often happens is I may ingress data center A, consume services in data center B, because that's where the extension went to, that's where the compute for that particular application is. And then when I go to egress, where do I go? Do I go back to data center A, where I originally ingressed, or can I just shoot straight out data center B from an egress standpoint? Throw firewalls in there or any other stateful type device like the load balancers or WAN optimization. Now I have the tromboning issue, where even though I've done my compute in data center B, I've got to get back to data center A, because it's data center A's firewalls that actually hold my state. So that's as I understand it, that's the tromboning people get concerned about. Now, we've talked about geography and distance. A lot of times, that amount of time, even with the trombone, is not perceivable to a user. Right. Of a service, right? So while as network engineers, we may know what's going on behind the covers, and we get a little twitchy about the fact that we know traffic's going back and forth, and perhaps we have to keep an eye on bandwidth because we're potentially doubling the amount of bandwidth that we're consuming across that DCI. But a lot of times, understanding that, yes, I've got to return to that original data center, is just something that the network team and the operations teams are aware of, but not necessarily even system administrators, application owners, or customers are actually aware of the fact that they're bouncing between data centers before they get the traffic back to them.
Yeah, I agree with that. Traffic tromboning in itself is not necessarily an issue, but it is something you have to be aware of.
Can I disagree with that for a second?
Oh, well, please do.
Can I disagree with that? So if
I would
you stretch
disagree
the
with you.
latency far enough, it's going to happen, because we actually had traffic tromboning. So I agree with Chris, when you hit a certain latency threshold, absolutely, they may not notice it, because depending on what you're tromboning between, you certainly may not notice the issue. One of the first lessons I learned when I did this a few years ago was, don't ever divorce the application from the database between two data centers, because really bad things happen.
Yeah. Oh, you get double trombones.
It was tromboning. It was before we had implemented, I think Nicolas mentioned, first hop redundancy protocols with multicast filtered so that you could egress your local data center. All the things that you learn when you first do this. Yeah, that's a lot of fun. Yeah, that's good times. But when you stretch the latency far enough, it kills everything. Everything just dies. So I agree with Chris in a certain latency window, but when you get into international, it can get ugly quickly.
Now, I got excited because you said you were going to disagree with me, but I don't disagree with anything that you just said. I was going to say the problem in and of itself isn't a problem. It's you have to factor in what the effect of the trombone is. Latency is going to be part of that. Bandwidth is going to be part of that. And you said doubling bandwidth, and it may not be doubling. Like you said, it could be quadrupling bandwidth. Yeah. And it may not just be a multiple or a straight multiple like that, because some things are asymmetric in the amount of bandwidth that's required. So while the request in may be very, very light, the response may be very, very heavy, and it may be 8 times the traffic that you would have normally had if you had egressed the local, even just on one request, not just twice. And so you have to really understand your traffic profile. If latency isn't a concern, you can buy your way out of tromboning by buying more bandwidth, but you can't fix the latency issue. Latency is a deal breaker, right?
It really is. It affects it a lot when you're trying to deal with that.
Right. And there's kind of some competing things here we mentioned, and we're kind of getting into mitigating the risk, but the idea of this, do I locally route, or do I send it back to where it came from to maintain the stateful? So we want to see the efficiency. We want to see, okay, if this data center B, if I'm replying to traffic, I want my router to be in data center B to make the decision about where it goes. But now we run into, how do I ensure the return path is the same, so we don't step and try to send return traffic through a different firewall than what it came in, and
fall in love with /32 routing,
which isn't data center interconnect. Now you're routing.
But that's a good point, though. You bring up /32. I mean, just as a side note, it is. We are seeing routers and switches with much larger tables than we had in the past. So a lot of us grew up on aggregate, right? Hey, roll this up into a /16 so that I can hide the bad things that are happening outside of a summary. But we are seeing with those bigger tables that people have moved to, hey, I'll announce /32s. It's not that big of a deal. So I think Lisp and some of the other ones kind of led to the idea of, well, wait a minute, the hardware and software is capable of it. Maybe we can leak some more specific routes to kind of help with some of that back and forth.
And I will bring up a very specific point that I ran into that you got to be really careful of if you're ever dealing with a network migration. One thing that you may or may not have run into is if you've got a bunch of MPLS clouds that you're going to be advertising these across the DCI. And I know I'm jumping a little bit because you mentioned the /32. One of the things we ran into in trying to mitigate with /32 to return traffic to the right data center for stateful traffic with layer 2 DCI is that traffic that had to get advertised into an MPLS cloud for reachability for some other things. And one of the things we found specifically with a network merger is MPLS PEs, depending on who you buy from, are typically they only carve out a certain amount for organizations, to use. And so if your routing tables get too large, most MPLS PEs will top out at 5,000, 8,000. Sometimes I've seen it even as high as 10,000 routes.
You're being generous sometimes. Some are way smaller. Yeah,
you're right. Some of them are even smaller. And so we actually had a case where one day everything stopped routing. We dumped a bunch of 32s in to fix a problem, and they were like, "Yeah, everything's gone." We're like, "We're looking at the routing tables. Everything's good. Everything looks great." And come to find out, the MPLS PE had run out of reserve space. And so that was, it's not strictly L2DCI. It was a challenge that we ran into because of that mitigation.
That's a great point to bring. Yeah, probably if we, summarize at some point during the show that, what are the things to look out for, that would definitely be a lessons learned, a scar that you have of, hey,
that was a scar.
I need to make sure the WAN
scars,
yeah.
MPLS routing tables are not indefinite. Like that's
MPLS. You just gotta pay for it.
Just like jumbo frames come up the same way, right? I mean, we are talking about in almost all these cases is an encapsulation methodology. And if your provider, if you don't own the fiber and you're getting that fiber, that transport from someone else, jumbo frames becomes an issue, right? So I ask my customers, I advise them all the time, you may have jumbo frames on your primary path, but you better ask your service provider 222 times, are jumbo paths enabled on every single primary, secondary, and tertiary path I may take during the maintenance window. So another lesson learned.
Yep. All right. So we've talked, and I had a thought there along the /32. So /32 networking is really what we're seeing, manifests itself in some of these overlays as well. When we talk about some of these more SDN style fabrics, right? Whether it's EVPN or, name the flavor of the week of whatever L2 overlay, L3 style it is, but a lot of them are doing that, right? And they're interjecting not a /32, but rather a /48, right? For the MAC address and its adjacency information into that table. Same idea. Host is there. We're going to have larger routing tables, just know right where it's at. I think that concept, the idea that we have more resources is allowing us to do that is kind of why we're seeing some of those changes.
Yeah. All right, Jordan, just to I guess to clarify that point too, the /32, typically when I use that is in network migrations. When you're doing network migrations and mergers, I think that's when the /32 comes into play the most, because you're dealing with things that you may have not designed that way or wanted to be that way, but that's the way it is. So I would say /32 probably wouldn't be my go-to if it was something I was designing from the ground up. It's kind of more of a reactive mitigation type stuff. Well,
and there's a limitation on that as well, right? So when we're talking about internet edge, like it's great on MPLS or private WAN link, but when you get to the internet edge, find a provider who'll take anything less than the /24.
You actually can do that. You just can't do it outside of that provider. So a lot of providers will let you leak less than a 24, but they won't ever advertise it outside of their space.
Sure. So there's complications there as well as it relates to the internet edge and how to get traffic to the right data center if you're sharing segments. So I want to talk a little bit. We keep going back to these mitigation things. We talked about BPDU filtering. I want to talk about why. Why is that important? Why is filtering BPDU between data centers? Why does that matter?
Why? I need to take a shower now. We are saying some bad words. I need to take a shower.
Well, I mean, we went from free range BPDUs to caged steroid BPDUs. They're tasty now, but probably not very good for us. No, why are we filtering BPDUs on DCI links? Come on, guys.
So we've talked about, spanning tree was great, and it's served us for quite a period of time. We've seen a lot of effort to either enhance that or displace it, right? We saw Trill and several other technologies come, and some of them left already. But I think to me, the BPDU issue is, to Yvonne's point, I may have a great service in data center 1, but if something goes sideways in data center 1, I do not want that propagated to data center 2. I do not want to be standing on the carpet of the CIO explaining that, yes, they spent a lot of money giving me the second data center, and I blew it up in 2 seconds, just like I blew up the first data center, right? So filtering BPDUs, whether that's something you have to do manually or something that's automatically done for you, depending on which manufacturer you have. The idea of I can have a spanning tree domain that's unique to each data center, I think is very important, not to propagate those bad things from happening from one to the other.
It really solves 2 problems, right? The first is propagation. The other 2 is layer 2 pathing, right?
Yeah,
because if our spanning tree route for our VLAN or whatever segment we're on exists at data center A, but I'm in data center B, even if I have a gateway on data center A, if it's not part of my tree, I got to go all the way over there from a frame perspective to make it back. Right. And that may be before my IP packet trombones.
Yeah.
So that comes with the importance of where should we place the root? Where should you put the root of your spanning tree domain? And that's something that is really, really important in that kind of consideration when you want to filter BPDUs between 2 data centers.
Right. And without filtering, there's no right answer, right? It doesn't matter whether you put it in A or B, it's going to be the wrong answer for whatever hosts live at the other side, right? And so you have to filter it from a pathing perspective, but we also do it right because of those propagation issues. We definitely don't want to see, spanning tree related outages causing spanning tree related outages in our other data center, because shared fate is a bad thing. Is that right?
Yes, it's a bad thing. It's a bad thing.
So also in that we've talked about limiting broadcast, multicast ARP, like it's a lot of the same things there. So in there we're talking like storm control, we're talking filtering those things. And like Chris has brought up multiple times, sometimes this is something that's done in the protocol, and sometimes this is something that you have to do yourself. So in Phil's example where, data center is, 10 blocks away and this is a temporary solution, maybe I just put some sort of broadcast control on that trunk, make sure it doesn't exceed a particular percentage of traffic. And that way, if I do get a storm, at least I'm not propagating all of my link speed of that traffic across, right? Whereas when you start talking about some of the more advanced solutions, it's going to be built in. The idea is that we're not going to allow broadcast to go that way. But one of the problems that comes up with this when we start filtering these packets, right, is unknown unicast. I know this is something that UTV takes care of, but the idea is when I don't know how to get to an address, typically I broadcast for it. Right. And if I don't know where it's at and my broadcast doesn't make it across the link, I need a router to respond for me. But if that router doesn't know where it's at, it has a hard problem responding as well. And so I know this is a problem specifically in UTV where you have to, OTV, where you have to explicitly, the perfect example is if you have a NIC that's specifically set aside for vMotion and you haven't done a vMotion in like 6 hours, that NIC's MAC address is not in anybody's table, right? It just doesn't exist. And so now all of a sudden I'm trying to do a vMotion from A to B and I can't get to it. So I want to bring that up, that if you're looking at it, it's one of those things you have to consider. How does unknown unicast get handled in whatever protocol you choose? Because some of them handle it differently than others.
You guys have any experience? You guys don't hard code all your MAC addresses in your environments?
Yeah, I mean, on my core switch, I just take all the MAC addresses and put them in there. Yeah,
that's what I thought.
Everything at this point.
That's what SDN is for, Phil. That's what SDN takes care of.
Oh, I'm doing it with Ansible, doing it
right.
the right way.
Oh, the right way. You've automated your static MAC.
Exactly.
Awesome.
Right. That was a joke, by the way.
That was the best answer of the night.
That was a joke, by the way.
Nick wins the episode. Very nicely done. All right. We talked about localized unicast gateway. So the idea of having a layer 3 gateway at each side, some of the complications around that, and stateful devices. So we won't harp on that any longer. So we've hit on some of these, but I want to take a second to talk about maybe some of the misconceptions. Like, what is layer 2 extension and what isn't? And I'm going to bring up my favorite one, and I know you guys are going to disagree with me because we've had spirited discussions around this. I don't see layer 2 extension as DR. I just don't. I think that even with all of the mitigations, DR being disaster recovery, sorry, acronyms, initialisms. I think the problem for me is that with all of the mitigation of shared fate, we're doing one of two things. Either we have a shared fate problem, or we're using tricks and breaking the way layer 2 works to specifically make this conglomeration of things happen and not kill us in the process. And so to me, I look at DR and I say, I have site A and I want it to be as different from site B as possible. I don't want them to share anything with the exception of being able to host the application that I need to. And layer 3 is the way to do that. Maybe that whole bubble routing thing is the way to do that because they don't share any resources at the same time. But I feel like if you need layer 2, there are some times where you just can't get away from it. But then I don't really feel like it's a true disaster recovery scenario because now I've introduced risks that didn't exist elsewhere strictly because of this limitation. And I'm gonna shut up now and let you guys say you're wrong.
Well, I mean, if you're talking about an entire DC outage, then yeah, I see where you're coming from. But what if you just lose a rack with, a certain application and you have to spin that up somewhere else, So I don't see it necessarily as it's a tool and therefore part of a disaster recovery plan, and a business continuity solution for a particular application. So I'm going to bring my Exchange servers up over here, and there's other things that we do. I know where again I've mentioned DNS again because we do lean pretty heavily on that for DR. So it really is just a tool. So I don't necessarily look at it as DR or not DR, but it's part of how we configure DR for a particular application or for the entire data center, which is I think kind of what you were talking about.
Well, not necessarily. So if you do a routed solution, it's segment by segment.
Yeah.
Right. Like that becomes your lowest common denominator. I can't have a segment live in two places. So my failover mechanism can only be as granular as the segment size. So it doesn't have to be a whole data center. It could be a segment. But when you're talking about a rack, I can't just fail a rack.
Well, I presuppose that a rack is a subnet, Wow, you have really organized data centers.
So Jordan, I'll go ahead and disagree with you.
Do it. Come on.
I will say, here's what I'm going to say is, and I've worn the hat of a team lead engineer, working before I became a consultant. So, I viewed things a little bit differently. Now I'm a consultant, so I view the world a little bit differently. But I think, whatever you're faced with and whatever you're given is the challenge that you have to solve. So if you've got a company that's invested $10 or $15 million into an app and they're not going to go redesign it, well, that's what you've got. And so, if L2 is the way you've got a DR, that's what you've got to work with. So I don't disagree with anything that's been said in the sense that we should push for a layer 3. We should push for better application programming. We should, say, hey, we want to move the complexity to this point because that's where we want it. But at the end of the day, what you've got to work with is what you've got. And if that's the mechanism by which you have to DR, because that's the way the app is designed, then I think that's something that you eventually say, okay, I'm going to own that, and then I'm just going to deal with it. I'm going to design it.
Please understand that when I say that, I've implemented lots of DR solutions that include layer 2 data center interconnect, not because I like it as a solution. I just don't consider it true DR, because if I was sitting in the business's seat, I'm looking at all that shared fate, and that's what has me concerned.
Well, and so it depends on what is going to flow over layer 2, because I've seen some application implementations where there's not really a lot of chatting between data centers unless you do have to declare a DR. So, I've seen some built in such a way where the application is really self-contained within its data center because the load balancers and the application infrastructure really keeps it confined to its data center.
Which is the way
that you need to move.
Should be, right?
Well, yeah,
in my mind,
it isn't always. But.
No, you don't pull the consultant answer on me here. It's not. It depends. Right?
It really is. So here's the thing. And I look at this too because I'm a business owner. So sometimes, I look at the financial aspect too. Is that I empathize with somebody that says, "Hey, I just spent $20 million getting these guys to code this, and I don't want to change it." I wouldn't want to spend $20 million either. So, I get it from a geek and from an engineering standpoint, and we want to, fight the good fight and push for things. But the reality of the financial and business situation is that, at least in my mind, and I'm going to go ahead and say this, I hear all this, we should have layer 3 should be everywhere. I hear it from the web scale guys. The apps should all be layer 3. Most of my world, most of the apps are not layer 3 resilient. A lot of them are not. The newer stuff that's in the cloud, yeah, but the stuff that most enterprises have, it's not.
I don't see the same thing, and maybe that's why I hold the opinion that I do, is that when I start digging in on the apps that my customers have, almost all of them can be solved with a layer 3 solution. Almost all of them. I do on occasion, and in those cases, you can't argue it, right? Like you need layer 2 adjacency. That's actually part of the requirements. But it really comes down to, and I guess I set myself up with a softball here. I think that we're moving complexity from layer 3 to layer 2, or not from layer 3 to layer 2. We're moving complexity from the application stack to networking because we don't want to deal with the complexity in the application world. And so I can appreciate your scenario in which someone spends $20 million writing an app. I can't how do you tell them?
But you're saying we don't want to deal with it. It's not like I have a choice. It's not like I made the decision. Somebody else made the decision.
No, but I'm saying we as let me rephrase that. I will say IT organizations generally, and of course this isn't everybody, and broad brushstrokes don't apply to everybody. You get the idea.
Sure.
But what I'm finding a lot of is, I want to be able to vMotion because I don't want to have to figure out what it takes to do a DNS style failover, or to have this application live in 2 segments, or to pay the money to update my app, or to spend that time doing those things. And so in that, we kind of just default, well, I know there's a tool to do this in layer 2, so let's just do it there. But when we do that, the complexity isn't any more or less complex. It's about equal level of complexity, most likely in my head. There may be situations where that's not true. But instead of addressing the complexity in the app layer, we've done it there. And then we've added risk that wouldn't exist if we had done it at the app layer, and may not exist at all if we did it at the app layer. Like, you have to look at the whole equation. And I don't see, and this is my blanket statement, I don't see my customers doing that. Looking at the complexity versus risk versus where does it make sense to actually do this. I think people default to layer 2 because that is the easiest to implement, because there is a vendor who will provide me a product to do it. Right.
Now, do you feel better? So in those scenarios, do you feel better, or would you feel better if you could just pick off and be very strategic about what gets extended?
Yes.
Right. Because you have the philosophy of, any VLAN could be anywhere. Doesn't necessarily mean every VLAN should be everywhere.
Oh yeah,
right?
Yeah. When you have to, you try to minimize it, right? You say as little as possible, as little distance. All of the trade-offs we talked about, we try to mitigate as many of them as possible. But not every VLAN everywhere. It's not usually how it gets presented to me when we start, right? It's usually, we have this data center here, we want this data center here. We want them all to be the same. Yeah.
Yeah.
So, okay, I'm going to get off my soapbox now. Sorry, guys. Anything else? Let's see. Anything else along that idea? Misconceptions, now that I've set myself up for 2?
I'll bring up my misconception of, one of the, and you and I have talked about this, is that, one of the biggest problems with layer 2 is that the wrong tools, in my opinion, get used to solve it. And we talked about this with using, I spent a lot of time in the ISP world. And so, you say, okay, we want to take Ethernet and we're going to extend it a distance. Well, there's protocols for that. There are protocols that exist to take Ethernet and extend it a distance, but we don't want to use those because that's, I'm not familiar with that. I'm not comfortable with that. And I totally get that, I get that. But like, in my mind, it's like, well, OTV didn't always exist, but we went out and figured out how it worked and we implemented it. So, there's things in the carrier world, because in the carrier world, it's, and that's, kind of the lens through which I view the world. And I have this kind of enterprise on the side, that I work on, but it's layer 2's everywhere. We do tens of thousands of VLANs stretched across the world, all over the place. And I'd say the vast majority of the aggregation and last mile of most carrier networks is all layer 2. So there's all these mechanisms to deal with the vast majority of problems that were mentioned. And I oftentimes feel like we get, shoehorned and pigeonholed into, well, we got to use this because this is what we have and this is what we know. And so rather than take a technology that was purpose built, to take Ethernet and stretch it a distance, and well, let's go use that.
That's a really good point.
So for the eager beavers who want to go out there and Google once they listen to this, what are some of those protocols that you're thinking, because they don't know that they're there?
So I would say the things that I would look at, one of the MPLS is probably my favorite technology to use to do DCI, simply because MPLS solves a number of problems.
But that's really layer 2.5.
Oh, wow. Should we go back to that? Oh, man.
Oh, we don't have time for that fight. That's going to be another episode.
Let's tag layer 2. Okay.
Yeah, great. So I like MPLS, and then VPLS has got a number of extensions to it. And in fact, if you even dig into VXLAN and AVPN, which I haven't had a use case to put into data centers yet, but there's a dependency on VPLS even with those, simply because MPLS solves so many problems. So if you get into a situation where you're like, we're going to connect these things and then we have no idea what we're going to do in the future. We may have to do this, and we have different business units and we have all these different requirements. I like MPLS because it opens up options. And one of the things, and this is probably the service provider coming out in me, but I like to build a network infrastructure so that I've got options that when somebody comes to me and says, hey, we got to do this, and there's no choice, I don't have to take the network back down to do it. I can put an overlay and take something and send it across and do it in a very safe way. And I even have to counsel my service provider clients on this, because a lot of them, especially smaller service providers, are like, well, why would I do MPLS? I'm like, why wouldn't you? Because it solves so many different problems.
I'm looking for your BGP hammer back there. I'm not seeing it.
Yeah,
I'm looking for that.
I got an MPLS network behind me. So,
yeah, that is true.
That's the best that I got. So I even have my hashtag Big Trouble in L2DCI back on the whiteboard.
All right. I think we're going to have to end it there.
So VPLS, to answer everyone's questions, VPLS, Advanced VPLS, and Ethernet Virtual Circuits. Check those out if you want to look at some carrier standards, and Metro Ethernet Forum Ethernet.
All right. Well, thanks so much to our guests. It definitely got spirited there towards the end, and I appreciate that. Very much value your opinion. Thanks for those of you who have lasted this long into this show, which I'm sure at this point is going to be somewhat over an hour, our longest yet. So before we jump off, I would just want to give our co-hosts here opportunity to introduce themselves, tell you where to find them. Yvonne, why don't you share first here?
Yeah, I'm Yvonne Sharp. You can find me on the blog at esharp.net or on Twitter at Sharp Network.
All right. Phil?
Hey, I'm Phil Gervasi. My blog is networkphil.com and Twitter is at network_Phil.
All right. I'm Jordan Martin. You can find me at jordanmartin.net or at bcjordo on Twitter. If you're looking for more networking content, either video like you're watching now, or if you're listening to us audio with the audio feeds, the best place to find us is at thenetworkcollective.com. You can also find us on Twitter at netcollectivepc. Next week, that's right, just 1 week away, we're going to be releasing a new episode. That episode was recorded at Cisco Live, so keep an eye out for that. And then 2 weeks, we'll be recording our next community roundtable. And that's going to be on some fundamentals of wireless. That one should be fun. I'm looking forward to that episode. So until then, thanks a lot.